Okay, so the new chapter is kinematics. In this chapter, first of all, we have to define few physical quantities. Number one is the distance. Definition of the distance is it is the length between two fixed points. So distance is the length between two fixed points. It is measured in meter and it is scalar physical quantity because it has no fixed direction. And the second definition is the displacement. The definition of this displacement is distance between two fixed points in a specified direction. So it has a fixed direction. So it's a vector physical quantity and measured in meters. So both distance and displacement are measured in meter. One is scalar, other is vector. And the third is the speed. Definition of the speed is distance covered per unit time is called speed. Or we can write rate of change of distance is called speed. Now the speed formula, V is equal to distance divided by time. For the distance, D is used, S is used, X is used. So these are the symbols for the distances. So suppose we use here D, we can use S, we can use X, anyone. So D divided by T or S divided by T. So V is equal to, when distance divided by time, distance measured in meter, time in second. So the speed unit will be meter per second, and it is scalar physical quantity. So speed is equal to distance divided by time. Now, this formula can be written as speed into time, but it has limitation. It is only valid when speed is constant. We can use this formula if the speed is constant. If the speed is changing, it is increasing, decreasing, then it has no use. So use this formula only when the speed is constant, okay? But speed cannot be constant for all the time. Then for the changing speed, we will use formula, the average speed into time for the distance. So distance is average speed multiplied by time. And this is symbol for the average. Now, the average speed is equal to total distance divided by total time. Total distance divided by total time. And this is the formula which is used in all cases. But if the object is moving in one direction, its initial speed given, its final speed given, then the average speed, which is written like this, can be written as v plus u plus v over 2. So this is the average general formula, total distance divided by total time, but initial and final speeds are given in one direction. Then the average formula will be u plus v divided by 2. If we substitute this here, then the formula is distance is equal to, instead of the average speed, we can write v plus u divided by 2 into t. And this is called basic or fundamental equation of the kinematics. Okay, so this is the distance, average velocity, average speed times t. Now the next definition is the velocity. It is rate of change of displacement, or we can write distance covered per unit time in a specified direction. So rate of change of displacement, or the distance covered per unit time in a specified direction, and the velocity is equal to displacement divided by time. It is measured in meter per second, and usually we write v is equal to d by t, or s divided by t. So it's a vector physical quantity measured in meter per second, similar to the speed, but the difference is it has fixed direction. Now the next definition is acceleration. It is defined as rate of change of velocity is called acceleration. Rate of change of velocity is called acceleration. So acceleration, small a, is equal to change in velocity divided by time. This change of velocity has unit meter per second, because the change of velocity is also the velocity, the difference of two velocity, so meter per second, but the time second, that's why it is meter per second square, which can be written as meter second power minus 2. So velocity vector, acceleration is also vector, it has fixed direction. Now, in our syllabus, there are three ways to change velocity. This is called delta V, mean the change in the velocity. Number one, by increasing its magnitude. Mean by increasing the size of the velocity, velocity is changing, then the acceleration is positive. This is the first way to change the velocity, by increasing its magnitude. And number two, by decreasing its magnitude. And here the acceleration will be negative. And the third is by changing velocity direction. Direction of the velocity changing, so velocity is changing, and here the acceleration is called centripetal acceleration. So the change of velocity is number one, due to increase in magnitude, number two, decrease in magnitude, number three, by changing the direction. And this negative acceleration, sometimes called deceleration, and sometimes this is retardation. So the acceleration is the change of velocity, and the change of velocity three ways: increasing magnitude, decreasing magnitude, and changing direction. Now, the formula, the last one, acceleration is equal to the change in velocity divided by time. So here the change of velocity can be written as final velocity minus initial velocity. So A is equal to V minus U divided by T, which can be written as A times T, V minus U, or U plus AT is equal to V, and it can be also written as U plus AT, this one. And this is called first equation of kinematics. And do remember, it is only valid when acceleration is constant. If the acceleration is increasing, decreasing, then this equation is not valid. So we will use this equation when the acceleration is constant. Now look, usually majority of the motion starts from rest. So initial velocity 0. When the object will start its motion from 0, then the equation will be V is equal to 0 plus AT, and V is equal to AT plus 0. Now this acceleration is constant. So there are two variables, time and velocity. Now, this time is the independent variable and the velocity is depending on time. So when we will compare this whole equation with the straight line equation, y is equal to mx plus c, the x-axis will contain time, the y-axis velocity, the y-intercept is 0, and this a is the gradient. So when you will compare the equation with a straight line equation, time will be plotted, time will be drawn on the x-axis, velocity on the y, or speed on the y, and acceleration will be the gradient. So the graph for this equation, time at the x-axis, speed velocity at the y-axis with unit. So it's a straight line passing through the region because the y-intercept 0 and the gradient is positive, acceleration is positive. So the gradient of this graph will give you the acceleration. And the next, area under the graph, area means length into width. So speed multiplied by time, the area will give you the distance covered by the object. So acceleration is the gradient, or gradient is the acceleration, and when area is calculated, the distance is determined. But if the question is, no, the initial speed is not 0, then we will draw another line with non-zero y-intercept. We will draw here some line parallel to the previous one. So this y-intercept will give you the initial speed. Both lines will be parallel if the acceleration is same. So this is the graph for the first equation of kinematics. Now suppose we have fundamental equation of the kinematics, which is distance is equal to initial speed plus final speed divided by 2 into t. We have done. And now the first equation of motion, v is equal to u plus at. Now we can replace this v in the fundamental equation, the basic equation from this equation. So distance is equal to initial speed plus this v, which is equal to u plus at divided by 2 and whole times t. Look, I just replaced v with the first equation, this u plus at. Now the d is equal to u and this u, it becomes 2u plus at divided by 2 into t. Now this t is multiplied with both. So distance is equal to 2ut, at into t mean at square divided by 2. Now this t is divided by both 2ut over 2 and at over 2. This is common divider. So we will write here d is equal to 2ut over 2 plus at square over 2, 2 cancelled. So distance is equal to ut plus 1 by 2 at square. And this is called second equation of kinematics. Okay. Now, again, if the motion starts from the rest, u0, then this equation d is equal to 0 times t plus 1 by 2 at square. And do remember, this is also valid when acceleration is constant, otherwise useless. When acceleration is constant, then we can use this equation. Now suppose u is 0, so this is a term. So it can be written as u is equal to 1 by 2 at square plus 0 into t at 0. Now again, this acceleration is constant, 1 by 2 constant. So t square is the variable, and the next variable is the distance. So when we will plot it on the graph, like the straight equation, a straight line, then y is equal to mx plus c. So the t square will be plotted at the x-axis, d at the y-axis. Then this one half a will be the gradient, and the y-intercept is 0. This is the case when initial speed is 0. So the graph at the x-axis t square, so we will write second square. This is the region, and here the distance in meter. So it's a straight line passing through the region. And the gradient of this line will be half of the acceleration, this portion. And the area of this will be nothing in the physics. So if the acceleration is calculated, acceleration is required, then the gradient times 2 will be the acceleration. So this equation is between the distance and time square. So whenever the equation is plotted, when the graph is plotted between distance and t square, the gradient will be equal to half of acceleration and area nothing. Now the speed initial is not 0, then definitely we will write the equation, this one, d is equal to half at square plus ut. So this is the gradient. This is at the x-axis. This is at the y-axis. And this is the y-intercept. So there will be positive y-intercept. We will draw this line. And this line gradient is again half of the acceleration, but this y-intercept is the product of ut, because the y-axis is distance, so speed multiplied by time is distance. So this is y-intercept, which is equal to ut. Now move to the next. Again, the basic equation is u plus v divided by 2 into t. And your first equation is v is equal to u plus at. Now, we can change the shape of this first equation. We can write v minus u is equal to at, or v minus u divided by a is equal to t. Now, we can replace this t with this t. Replace the t from this first equation, t expression. Then, distance is equal to u plus v over 2 and times t from this v minus u divided by a. So it can be written as then distance is equal to u plus v into v minus u divided by 2a. Now, according to the mass formula, a square minus b square, a minus b, a plus b. So look at this, a minus b, a plus b. So it will be equal to v square minus u square. So distance is equal to v square minus u square over 2a. Now 2a d, this a 2a multiplied with d is equal to v square minus u square, and then u square plus 2ad is equal to v square. So finally we can write v square u square plus 2ad. This is the third equation of the kinematics. And again, it is only valid when acceleration is constant. This is the derivation of this third equation. Now suppose again, the initial speed is 0, then the equation will be v square 0 plus 2ad. By rearranging, we can write 2ad plus 0. And we have done that this acceleration, this number 2 is constant. So two variables, one is the distance, another is speed. Now speed is depending on the distance. So when we will plot the graph, y is equal to mx plus c, x will be on the d will be on the x-axis, v square on the y-axis, then 2a will be the gradient of the line, and the y-intercept will be 0. So the shape of the graph will be, at the x-axis, we will plot the distance in meter. At the y-axis, we will plot speed square, unit meter per second, but we have to write whole square. It's a straight line passing through the region, but gradient is equal to double of the acceleration, and area here is again nothing. And if u speed, initial speed is not 0, so there will be positive y-intercept. So this is the line, and this will give you the u square because the term is u square. So this is the graph, the third equation. So we have one equation, distance is equal to u plus v divided by 2 into t. then V is equal to U plus AT, then D is equal to UT plus 1 by 2 AT square, and then V square U square plus 2AD. You can write D, you can replace D with S. So 1, 2, 3, and 4 with the graph. If the graph of this plotted, the gradient is acceleration. If the graph of the second plotted, then the gradient is the half of acceleration. If the third graph plotted for this equation, the gradient is double of acceleration. And the next, if the question is initial speed is 0, sketch plot V against D graph. This is V square against D, V D graph. So we will take help from the third equation, V square U square plus 2AD. So it can be written as V square 0 plus 2AD, or V square is equal to 2AD plus 0, but V is required. So we will divide both sides by V. So 1V cancelled. So V is equal to 2A over V into D plus 0. So x-axis, this one, y-axis, this. So we have to plot the graph V at the y-axis and D at the x-axis. So this is V, meter per second. Now, this portion is the gradient. 2A over V, the whole is the gradient. Now, A constant, 2 constant, but the problem is V. V is increasing due to acceleration. So in denominator, in the fraction, denominator is increasing. So the whole fraction will be decreasing because the fraction, this whole fraction is the gradient. When V increases, this denominator increases, whole fraction value decreases. It means the gradient decreases. So we have to draw decreasing gradient graph. So this is the line if initial speed 0 and the graph is plotted between V and D. So this will be the gradient. It is not constant because the V is increasing, denominator is increasing. Thus, the gradient whole fraction is, if speed is not 0, initial speed is not 0, then definitely the curve will start from this position. So look at the graph. This is the graph between V and D, and the gradient of each line is 2A over V, which is not constant due to increase in the speed with time.